Hello students, welcome to Naran PU College online classes. So in the last video we have discussed about the sigma bond and pi bond. Clear no? So just to recall what we have discussed in the last class, last ending, sigma and pi bond I discussed. Clear no? You know that sigma bond is formed due to the overlapping of end-to-end overlapping of electron. That is clear no? End-to-end are head-on overlapping of orbitals along the intermolecular axis, which bond will form here sigma bond. Means simple, end-to-end overlapping, this is one end and another end. End-to-end overlapping sigma bond. Sideway overlapping, pi bond. Clear no? And sigma bond can be formed by three types of overlapping. That is, one is S overlapping, or SP overlapping, or PP overlapping. Clear no? But pi bond is formed due to only PP overlapping, not SS, not SP. Clear no? Pi bond will be formed only PP overlapping. Clear no? So that is the concept. And another small concept here, and pi bond and sigma bond is there. In case of sigma bond, in case of what is sigma bond, the overlapping takes place in a large extent. Clear? Because head-on overlapping are side, end-to-end overlapping. This is overlapping like this. This is overlapping takes place in large extent. Means overlapping will be very strong. Means you see, suppose if it is hand, you see this is head-on. Clear? So what will happen here? Overlapping will be very strong. Clear? This is, see, I can hold this hand. Clear? No? This is overlapping. This is sigma hand. End-to-end overlapping. This is overlapping means what is one? This is overlapping. This is sideway overlapping. Is there any chance to hold very tightly? No. This is. We can easily remove. If it is there strong, difficult to remove. That is sigma bond and pi bond. Clear? So sigma bond, it is. In case of sigma bond, overlapping takes place in a large extent. I already mentioned, and the strength of the bond depend upon extent of overlapping. Greater the overlapping, and stronger will be the bond. Clear? So that's why in case of sigma bond and overlapping takes place in large extent and greater overlapping, you can simply say. So that's why sigma bond is always stronger than the which bond here? Pi bond. Clear? Pi bond, because due to the sideway overlapping is not that much effective. So small extent of overlapping. So that's why what will happen? So the bond is not that much strong compared to the pi bond. So the bond is weak. Clear? And very important, remember always, pi bond alone cannot form. Always it is formed along with the sigma bond. Means just assume, and pi bond is there between the two atoms. The pi bond between the two atoms is always in addition with what is sigma bond. One sigma bond will be there and pi bond. Sigma bond can exist alone, but pi bond cannot exist alone. It is always with the existed with the what it is here? Sigma bond. Clear? So these are the some important points of what it is here? Sigma bond and pi bond. Clear? And also sigma bond is strong. If bond is strong, will it involve in the reaction very fast? No, because it is stable. Stable means less reactive. Sigma bond, if it is there, those compounds are less reactive compared to the pi bond containing molecule. So pi bond is there electrons are there, pi electrons, we can say pi electrons. Pi bond means pi, bond is formed by the pi electrons. Clear? So what happened here? The pi electrons easily involved in the reaction, more reactive those are. If sigma bond is there, one atom here, it is bonded with the sigma bond, then we can rotate these atoms along with sigma bond. But here pi bond is there. Clear? So pi bond is there, rotation is not possible. Got my point? So these are some important points of sigma and pi bond. Important question for your PI examination. So just now I want to write here differences between the sigma bond and pi bond. What we have discussed, that is only I have written here differences. The first one you see, the bond is formed end-to-end overlapping or head-on overlapping of atomic orbital along with the what it is internuclear axis. is called as a which one? Sigma bond. And this bond is formed by which one? Side wave overlapping. And side wave overlapping, it is the overlapping takes place right angle to the internuclear axis. Clear? So this is internuclear axis. This is internuclear axis. Along the internuclear axis, this is what is known perpendicular. This is perpendicular. Clear? So that is pi bond. You know, this bond is formed by overlapping of SS, R, SP, R, PP orbital overlapping. Clear? But pi bond is formed due to which orbital overlapping? Only PP orbital overlapping we will get pi bond. Clear? So it is a strong bond, just now only I mentioned. It is a weak bond. It is a strong and here, so that's why they are what is less reactive, and this is weak, so that's why they involved in this bond involved in the reaction very fast compared to the sigma bond. And the electron cloud is symmetrical across the internuclear axis. Clear? So, but in this case, if you see here, it is not symmetrical. It is unsymmetrical along the axis. Why? Because and pi bond when formed, electron clouding is above and below the plane. Clear about this? So that is. And sigma bond have independent existence. I already mentioned. Sigma bond alone it can exist. That is independent it exists. And pi bond always exists along with a sigma bond. Clear? So suppose if I mention double bond is there here. This is a single bond. This is double bond. It is triple bond. Just assume. So it is a single bond means it is only sigma bond. Clear? Single bond means which bond? Sigma bond. And if you take here in this case, clear? So what happened now? One is a sigma, another one is what it is now? Pi bond. If it is triple bond, one is the sigma, and the remaining two are which bonds? Pi bonds. Remaining two are which bonds? Here, pi bonds. That is means sigma bond can exist alone, independently. Clear? But pi bond it is exist along with the sigma bond only. If double bond is there, one sigma bond, one pi bond. If triple bond is there, one sigma bond, remaining two bonds are which bonds? Pi bonds. Clear? So that is it. So now there can be a free rotation around this bond. Means I already mentioned. If you take here, there is one atom and one atom, rotation is possible around the single bond, but and around the double bond, rotation is not possible. So this is free rotation is not possible around the what it is here, pi bond. And these are the very means important. This is very important question for your PU examination, and also. And here these points, and it helps you see here in this case. Sometimes what they will ask, they will give you one compound and they ask you to find out how many pi bonds are there, how many sigma bonds are there in that compound. And that time it helps. Clear? One bond is single bond is there, that is only sigma bond. If two bonds are there, one sigma, one pi. Three bonds are there, one sigma remaining two pi bonds. Clear? So this is about difference between the sigma bond and pi bond. So these are some compounds they will give, and you have to identify number of sigma bonds and pi bonds. Clear? Important question this is also in the PU examination, sometimes they are asking. Clear? So now, and the first compound is there. Whenever you are writing, you want to calculate the sigma and pi bonds, first you have to write the structure of the compound clearly. Clear? Now, here what is the CH2? Means carbon forms how many bonds? 4 bonds. Carbon by covalence how much? 4. So that's why it will form 4 bonds. Clear? So that's why first carbon if I take in the first one, here what is CH2 double bond means this carbon having 2 bonds, and here another 2 bonds are with the hydrogen. Hydrogen forms how many bonds? 1 bond only. Hydrogen cannot form more than 1 bond. So how to write the first one? I will write carbon, and here there is a 1 hydrogen and there is a 1 hydrogen. CH2. C and hydrogen and hydrogen. Here which bond is there? Double bond. Next which bond is there? C, and there is a 1 H. This is H. What my point here? Next one is what it is. And here there is a single bond, and carbon. To this carbon there is another H. And here what it is? There is a double bond, and last one is carbon and CH and CH. You have to write it this way. Then it is very easy to predict how many sigma bonds are there and pi bonds. Clear? Simple. You see now, this is single bond. Single bond means which bond? This is sigma bond only. Clear? But here this one is a double bond. Double bond means I mentioned one is a sigma bond and another one is a pi bond. Clear? And here it is a sigma. All single bonds are which one? Sigma bonds only. But here there is a pi bond. One sigma, one pi, and here sigma, and here sigma. Clear? So this is the number of sigma bonds. Now calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. How many sigma bonds are there? 9 sigma bonds. How many pi bonds are there? 1 and 2. So here 2 pi bonds. This is the answer. Like that we have to write. In the same way, write for the second one. Second one you see how to write. And carbon. And to this carbon, how many hydrogens are there? Hydrogens, 3 hydrogens. You know hydrogen forms only one bond because hydrogen is having 1 electron. So that's why here carbon is having 4 bonds or not? Yes. And to this carbon there are a 1 triple bond. And here for this hydrogen, hydrogens always indicate with the single bond. Then it is very easy to identify CH. And here there is a double bond. And here there is a CH and CH3. H, and one is not H. This is. So how many sigma bonds are there? You calculate. All single bonds are which bonds? No, sigma bonds only. And here triple bond is there. 1 sigma, 2 pi bonds. 1 sigma, 2 pi bonds. Clear? Here also sigma, sigma all. Here but here 1 sigma, 1 pi. Double bond is there here. Clear? So next one. This is sigma. All these single bonds are sigma only. Clear? So total how many sigma bonds are there? 1, 2, 3, 4. And here 5, 6, 7, 8, 9, 10, 11, 12, 13. So total how many are here? 13 sigma bonds. How many pi bonds are there? Here 2 pi bonds are there. And here 1 pi bond is there. Totally how many are? 2 plus 1, 3 pi bonds. Clear? That is the second one. And third one. Clear? Third one, what I have given here? Benzene. Benzene means this is the benzene. Clear? You see now. This benzene formula what it is? C6H6. What that is the benzene formula? See now. This is what? Carbon only. This carbon is forming how many bonds you see? Carbon is forming 1 and here pi bond. Total how many? 2 and here 1. Total how many? 3. And the carbon, each carbon, if you take any carbon here to this carbon, here 2 bonds are there, and here 1 bond is there. Total how many bonds? 3 bonds. Means here carbon is forming 3 bonds, but carbon should form how many bonds? 4 bonds. So that's why. And another one is here. They have not mentioned that one. So not hydrogens only. That is C6H6. So here each carbon will have 1 hydrogen. Each carbon will have what is here? 1 hydrogen. Actually we will not represent that. We will simply write benzene means like that only we will write benzene. Or we will write benzene is like this. Clear? But what is the exact one? This is. Now you know sigma bonds and pi bonds you can easily identify now. Clear? Identify how many sigma bonds are there. All these 6 single bonds are which one? Sigma bonds only. These are sigma bonds. Clear? And here this is a single bond. This is also sigma. This is sigma, this is pi. Clear? So this is sigma and this is, I am writing here. This is, clear? This is sigma. And here what it is? Sigma. And another one is pi. This is sigma and this is pi. Clear? This is sigma bond. And here also 1 sigma, 1 pi. Clear? So these are the bonds. Clear? Now how many sigma bonds are there? You see total 6 sigma bonds and here 1, 2, 3, 4, 5, 6. Total 6 plus 6, 12 sigma bonds. Pi bonds are there. 1, 2, 3. That is pi bonds. 3 pi bonds. This is how to write the stage. Will you write in the same way for the remaining 2 stages or not? And just do as a homework. Clear? So I am giving here another some questions also. Just you calculate how many number of OCH is there, number of sigma bonds and pi bonds. And another one is I am giving compound here C triple bond H and C triple bond H here. Clear? So next one is just to calculate how many sigma bonds and pi bonds are present in this molecule. This is what it is. This is clear? So if you take in this case also, just I will write the fifth one. Fifth one I will explain. Clear? So just remaining you just do as a homework. Clear? And here C, one H and H and H here. This is bonds. Clear? Here you see this carbon is having how many bonds you see? 1 and here 2 and this is 3 and here what is 4. So here this carbon doesn't have any hydrogen here because already having 4 bonds. But remaining carbons it is showing only 3 bonds to this carbon, 2 and 1, 3. So means fourth one is hydrogen. So all these carbons remaining first one we have what here sigma bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and here all these are sigma bonds. Sigma, 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 sigma. These are pi bonds. Clear? So here how many are there? We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? Once you count, these are 3 and here how many are there? 1 or 6 bonds are there. 1, 2, 3, 4, 5, 6. Clear? 3 plus 6, 9. 10, 11, 12, 13, 14, 15. Clear? This is also one sigma. Clear? So total how many sigma bonds are there here? 15 sigma bonds and 3 pi bonds. Clear? So this is how to do means this is the way to do. And remaining what I have not done here, we just do those questions as a homework to find out the number of sigma and pi bonds. So next one is failure of orbital overlap concept. So previous I have mentioned one concept if you see. So what is that one is the directional properties of covalent bonds. Have we discussed it now? Clear? So what it is and valency band bond theory to explain the characteristic geometrical properties of polyatomic molecules. What it is geometry or you can say shapes to explain the means shapes of the polyatomic molecules and VBD theory has introduced mainly 2 concepts. One is overlap concept and another one is hybridization of atomic orbital. Overlap of atomic orbital and hybridization of atomic orbital. Clear? So that I already mentioned. Directional properties of bond, covalent bond of polyatomic molecules to explain. And VBD theory introduced what is here overlap atomic orbitals or hybridization of atomic orbital. Hybridization of atomic orbital has given means clear geometrical shape or characteristic geometrical shapes or characteristic geometrical properties of covalent bond. How much bond length and what is the bond angle. But this is failed to explain. Why explain? Simple atomic orbital overlap does not account the characteristics of geometrical properties of polyatomic molecules like CH4, NH3 or H2O etc. So what is this failure? Suppose I will write simple here formation of CH4. What it is here? Formation of CH4 molecule. According to the orbital overlapping concept I will write formation of CH4 molecule. Formation of CH4. Clear? So according to the orbital concept, orbital atomic orbital they overlap. Clear? And forms a covalent bond. Clear? Covalent bonds will be formed. So suppose if I take what is the central element here? Carbon. Carbon, ground state. Carbon in ground state. Which orbital involved in the overlapping? Of filled atomic orbital of valence shell. Clear? That you remember. So here what is the valence shell electronic configuration? 2s2, 2p2 for the carbon. Means how many electrons are there here? There are 2 electrons here and there are another 2 electrons in p orbital. This is ground state electronic configuration of carbon. But if you take excited state, I already mentioned here excited state. Clear? So I have given some important points in the VBD theory. There I have mentioned. And if in this one valence shell, unpaired paired electrons also there, and they can also involved in the bond formation, overlapping, if they are converted into unpaired electrons for jumping from one orbital to another orbital. How that energy is energy comes. I already mentioned, when these carbon and hydrogen molecules, they are coming close to form a covalent bond, some energy is released. That energy is compensated here. That energy is compensated. So that molecule is gain that energy. This one of the electron will jump from the 2s orbital to 2p orbital. You need not to supply extra energy to make it transfer this electron from one orbital to another. Clear? So now what is here? You can simply say one electron here and another one electron will jump into the orbital. Clear? This is which orbital one? 2s orbital. Another one is 2px, 2py, and what is one? 2pz orbital. Means this is 2s orbital, 2p orbital, 2p orbital 3. That is clear. And now, and these orbitals, unpaired electrons are there. So these unpaired electrons are there, and here hydrogen is there. Hydrogen, hydrogen is also have one unpaired electron. So these orbital will overlap and form a covalent bond. First one, I will write here. One of the electron means this is a hydrogen. This is what is one. One electron is having with the hydrogen. Or simply I will write here. Hydrogen having what is one electron plus here carbon. Carbon 2s orbital is there. This is which orbital? 1s orbital of hydrogen. 1s orbital. Hydrogen I have already written here. Hydrogen. And here, what is one here? This is carbon. Carbon atom. Carbon atom which orbital here? 2s orbital. Carbon atom which orbital here? 2s orbital. Here it is also, and carbon it is also having what is one electron. It should have which? It is sign, opposite sign. It should have this sign over here, opposite sign. Or simply, I will write here, carbon and hydrogen I will write up. Clear? So here, there is a one electron. This is from which orbital? Hydrogen, and plus, this is unpaired electron in the opposite direction. This is carbon. Then what you will get? You will get a overlap. Overlap takes place between the atom. This is a carbon, this is a hydrogen, this is a carbon. This is hydrogen and what it is now? It is a carbon, 1s and 2s. This is what is now? 1s and carbon of 2s. You will get 1s and this is what is now? 2s. There will be a one bond. So here there are 2 electrons. 2 electrons means what? One bond. Clear? This is one bond is formed. Remaining how many bonds has to form carbon? Carbon has to form another 3 bonds with the 3 hydrogens. And now which orbitals are there? P orbitals are there here. I will write these are P orbitals. So this is one P orbital. So just assume PZ orbital. And this is PX orbital. And another one is what it is now? PY orbital. Clear? So just assume this is a PZ orbital. And this is what it is now? PX orbital. And this is a PY orbital. Each are having what it is now? One electron here. Clear? And PZ I will write. PZ one electron. Clear? Now, here how many hydrogens will come? And 3 hydrogens will come here. 3 hydrogens. Clear? These all are which one here? 1s. Clear? Now, they are overlap and gives here bond. Clear? See what it is here? There is I will write simply. This is, and here, and then is here. Clear? Now what happened you see? In this one, this is PZ orbital and 1 hydrogen, and PX orbital 1 hydrogen, and PY orbital 1 hydrogen. Clear? This is overlap. And now it is giving 1 electron, PZ orbital giving electron. This is one bond, and this is one bond, and this is one bond. Clear? So these are all which one? These are what it is? Hydrogens. Then how many bonds will form here? How many bonds will form? You will get the here what it is now? 3 bonds. But these 3 hydrogens overlapping with the p orbitals. But p orbitals are 3 p orbitals are and 90 degree to each other. Means px and py orbitals are perpendicular to each other, and pz and py orbitals are also perpendicular to each other. Now here the bond formed is, I can write here there is a 1 and 2 and there is a 3. 3 bonds formed here because this is one bond, this is one bond, and this is one bond. If I write like this is one bond. Clear? So now what is the angle between any of this bond? 90. Why? Because these 3 p orbitals are perpendicular to each other, so the bond should be formed here is a 90 degree. But this what is the direction this is? We cannot predict because 2s and 1s orbitals are spherically symmetrical. They can overlap in any direction. We cannot predict here. Clear? So that's why we cannot predict bond here, and but here we can predict. But you know these three bonds are equal length, bond length. But this is different bond length because here overlapping is different. 1s 2s orbital overlapping. But here you know 2p 1s, 2px 1s, and these are p and s orbital overlapping. This is 1s. And S and S orbital overlapping. Here PS and PS overlapping. So that's why here bond form is different from these three. These three bonds are same, but this is different. And here angles are how much? 90 degree. But it is quite means opposite to the experimental value. Quite different for the experimental value. What is the bond length? Total how many bonds it is forming? 4 bonds only. This carbon with here 1 bond. I will write simply. This is final structure. If I write suppose like this, clear? So like this if I write, this is bond is formed due to what it is now? This bond is formed due to SS overlapping. These all are SP overlapping. These all are which one? SP overlapping. So this bond should be different from these three. And its bond angle also here how much? 90 degree. But you know experimentally it is proved that the bonds all in the CH4 are similar, and the bond angle, if you take any bond angle, if you take between these, and it should be a 109. Actually it is SP. That I will write. Here what is the bond angle here? 109 degree. Tetrahedral shape it should be. CH4 is in which shape? Tetrahedral shape you already know. Then tetrahedral shape means I will write. It is experimentally you know that the shape of CH4 is equal to what? The shape of CH4 is tetrahedral. Clear? And what is the bond angle? Bond angle is equal to 109.5 degrees. Clear? What are bond lengths? Bond lengths all are same. Bond lengths what is all bond lengths are same. But here this is different compared to these three. Bond lengths are different and bond angle here 90 degree. So that's why what I want to say here, simple atomic orbital overlapping will not give the perfect shape of a particular molecule. Clear one? What my point here? Simple atomic orbital. These are what? Orbitals are atomic orbitals are there having unpaired electron, and here hydrogen is having unpaired means orbit orbital, and these orbital simply overlapping. That is very important here. What it is here? Simple overlapping of atomic orbital does not account the directional properties of polyatomic molecules. Clear? Simple overlapping of atomic orbital does not account for the directional characteristics of bonds, bond angles of the polyatomic molecules. So this is the failure of orbital overlap concept. So, and to overcome this, clear? So another one concept has been introduced that we will call as a hybridization. Clear? So we will discuss what is the hybridization, what are the conditions required to hybridization. All we will discuss one by one. Very important concept this is. Clear? Next concept is hybridization. Why it has been introduced to hybridization? Clear? Because overlapping concept is failed to explain the what is simple means atomic orbital overlap, that we will call as orbital overlap concept, is failed to explain the characteristic geometrical shapes of polyatomic molecules like CH4. I mentioned here. Not only CH4, if you take the water also, clear? You take H2O also. There also actually bond length and bond angle for the water is bond lengths all are same and bond angle is 104.5. But if you consider according to the orbital overlap concept, there also 90 degree will come. Clear? So this is failure. So that's why in order to explain the characteristic geometrical shapes of polyatomic molecules like what is CH4 and means methane, water, ammonia, and Pauling is introduced one new concept that we will call as a what it is hybridization. Clear? This concept is totally hypothetical. Clear? So that is, I will explain what is that one. Clear? So what is mean first of all hybridization? Clear? So what is hybridization means? And simple, I will take one example. In a class, in one class, some students are there. We conducted the examination. Then, and different students get different means marks. But we will take the. We are not considering how many marks means which one got the highest marks, which one is got the least marks. We will not consider that one. We need average of the class mark. Then what we will do? We will add all the marks. It will be missed. One is may get the highest marks, one may get the lowest marks. That doesn't matter. We will add all these marks and we will divide that one by what it is here total number of students. So average suppose 80 comes. 80 comes means what mark? Each student is getting 80 marks only. All marks are now same. What my point here? All marks are now means how much percentage means what is the average marks? What is the average percentage of the class? Here we will say 80%. Sir. Means what does it mean? Each student may get the almost 80 marks. Or 60% of the average marks of the one class is 60%. Means what we will what does it mean? Almost all are getting average what is 60 marks. Clear? So that is what it is hybridization. Clear? So this is a process of here instead of taking marks we will take the orbitals. Clear? What is that orbital hybridization means? The process of mixing of atomic orbital of the same atom or the same class, same atom. Clear? Of slightly different energies. That the orbitals are having what it was? Slightly different energies. Not exactly same, slightly different energy. So that redistribution takes place. What it is redistribution of energies takes place among them. Clear? Resulting the formation of new orbitals. Formation of what it is here? New orbital having equivalent energies and identical shapes. That concept we will call as a what it is here? Hybridization. Clear? Means I will take here some orbital and all orbitals are not having same energy, slight difference in the energies, and I will mix that one in the one mixer, just mix it. Clear? Then after mixing what will happen? And the redistribution of energy takes place between them. So suppose one is having 10 energy, 10 kilojoule, another one is 12 kilojoule, another one is 14 kilojoule. Now, after mixing that, what will happen? All are having 12 energies only. Means all are now having what it is? Same energies only. And shape also identical. And that process we will call as what it is here hybridization. The new orbital formed having the equal energies are called hybrid orbitals. Same. So this is the concept of what it is here. Hybridization, and that process we will call as a hybridization, and this was given by what is introduced by Pauling and Slater. It is totally what it is here. It is a totally hypothetical concept. It is a totally hypothetical concept, and it is why it is introduced in order to explain the geometrical shape of polyatomic molecules. That I will write, and you have to note down. Clear? So I have explained what is the hybridization. That I have written here definition of hybridization. Clear? So what I mentioned, that is only you see just the process of mixing of atomic orbital of the same atom of slightly different energies. The atomic orbital, suppose I will take px, py and pz orbital. Suppose yes, yes orbital 1, px orbital, py orbital, pz orbital I have taken. I mixed up all. Because I have taken only valence cell, so that's why almost they have similar energy, slight difference. So that's why I mixed that one. Clear? No? So after mixing what we have, that slight difference will be removed. All will have the same energy now. Clear? No? That is only. So different, slightly different energies, so that redistribution of energy takes place between them, those orbitals, resulting in the formation of new orbitals. And that new orbitals of having what they are having, what is one? Equal. Almost all the orbitals are having similar energies and identical shapes. Are equivalent energies and equal shapes, are identical shapes. Clear? And this is called as what is here hybridization. The new orbital what are formed, and those we will call as a hybrid orbital. We will take for examples, then what are hybrid orbitals, that you clearly get the picture. Clear? Next, I already mentioned it is a hypothetical concept introduced by which one? Pauling and Slater, in order to explain the shapes of polyatomic molecule, geometrical characteristics, geometrical shapes of what it means, their bond lengths and bond angles, all. That is, we cannot say directly geometrical shape, characteristics, geometrical shapes of polyatomic molecule. And very important here, and the representation of hybrid orbitals. How to represent means, it is like a p orbital, but one lobe is reduced. Clear? P orbital means what? How we will write? P orbital means W level. This is the p orbital. Clear? But how we will write for the hybrid orbital? How we will represent the hybrid orbital is, and we will represent in this. One is big lobe and another one is very small lobe. Clear? So this is minus and this is what plus. Like you see p orbital. P orbital means equal. One is minus, another one plus. But here, this is the representation. If you ask, you can sometimes what it is like this. Clear? So these are electrons. Orbital means what will happen? What will happen? So this is representation of what it is here. Hybrid orbitals. This is what it is here. Just right here. Representation of hybrid orbitals. Clear? So this is simple hybridization. Clear? Now, and here salient features of hybridization. Clear? So which orbital will involve in the hybridization and what are the some conditions? Clear? That we will see. So I already mentioned, slightly different energies of atomic orbitals will involved in the hybridization. That is the first point. Clear? So now the number of how many hybridized orbitals will be formed means how many atomic orbitals are involved in the hybridization, and those many hybrid orbitals will get. Suppose two atomic orbitals are mixing, then how many hybrid orbitals will get? Two only. Suppose three, one is s and two p orbital I mixed, then I will get the three hybrid orbitals. If I mix one hybrid and three p orbitals, so one hydrogen, one s orbital and three p orbital I mixed up. Then total how many? One s and three p. Total how many? Four. You will get the final limits. How many atomic orbitals are involved in the hybridization, and those many hybrid orbitals will be formed. That is the second one. Clear? So hybrid orbitals, you already know hybrid orbitals will have the equal energies and identical shapes. All hybrid orbitals will have equivalent energy and shape. Clear? So that is. And now, if you take next one, hybrid orbitals are more effective. Hybrid orbitals are clear? 1 minute. So here now I think totally coming. Previously it is coming off. Also that's only I stop here. Clear? See now what I mentioned here. Are only atomic orbitals, same energy involved in the hybridization, and number of how many hybrid orbitals are involved, atomic orbitals are involved, and those many hybrid orbitals will be formed. Clear? Hybridized orbital will have, I already mentioned, you see, you will get the new orbital having the equivalent energy and shape. So that means these new orbitals will be called as a hybrid orbital. These hybridized orbitals will have the equal energies and identical shapes. Clear? Now, second one. And the hybrid orbitals are more effective in forming the stable bond compared to the pure atomic orbitals compared to this, and hybrid orbitals will form the very effective bonds. So why means that we will discuss. Clear, no? So hybrid orbitals forms only sigma bonds. This is very important. Clear, no? Hybrid orbitals form only sigma bond. Pi bonds is always excluded. I forgot to write there what it is, yeah, that the pi bond is always excluded. Pi bond is always excluded from hybridization. Clear, that is. Means only sigma bonds we will get, not the pi bonds. Pi bonds means simple overlapping, simple orbital overlapping. You know, side by side orbital overlapping, you will get the pi bond. But hybrid orbital will not form, will never form pi bond. That is the another one. These hybrid orbitals are directed in a space, in a preferred direction, to have minimum repulsions between the electron pairs. You know already. Clear? So previous we used to say shape of the molecule, that is shape of the molecules in the form of electron pair. Electron pair, it will you know, when they are coming close to each other, bond pair repulsions will be there. VBD theory we have discussed. Bond pairs will come around the central atom. Around the central atom there are so many bond pairs and lone pairs. Due to that repulsions, these bond pairs move in a space, in the space. Clear? Then what will happen? If you connect that one, you will get the definite space, definite shape of the molecule, isn't it, man? So in the same way, these orbitals means what it is. You understand or not what I am saying? VBD theory we have discussed, isn't it? In the VBD theory, and around the central atom, bond pair electrons will be there, and also which electrons, lone pair electrons are there, and there will be because electron cloud, there will be a repulsion. So that's why these pair of electrons, to avoid the repulsions, they move in different direction and occupy definite position in a space, and that gives the what it is, shape of the molecule. But here in this one, in the hybridization, we will get the orbitals will, because orbitals means what? Orbital you have already studied in the atomic structure. Clear? The probability of the finding electron maximum in the orbital. Means orbital means they are having electrons. So that's why here also same concept, but we will not use electron pair here. We will use what is orbital. Clear? So that the hybridized orbital directed in a space in some preferred direction to have minimum repulsions between the electron pair and stable arrangement. Clear? Suppose a simple I will say one s orbital, one p orbital, px orbital, and one py orbital. These are atomic orbital, and mixed up you will get 3 sp2 orbitals. 1, 2, 3. 3 atomic orbitals. 3, 1s, 2 orbitals. Total how many orbitals? 3. And these 3 hybrid orbitals, how they arranged means, and they arranged in a space in order to minimize their energy. Clear? Means like this. Clear? This is, you know, atomic orbital means hybrid orbital. Hybrid orbital how we will represent in this way? This is another hybridized orbital, and this is another hybridized. Means simple, I am just don't write this one, and to explain I am writing this, and these are the important one. sp2 hybridized orbital. This is sp2 hybridized orbital. This is sp2 hybridized orbital. They are arranged in a direction to minimize the repulsions and to get the minimum energy. And in that way they arrange. What is the shape here? Trigonal means trigonal planar shape. Like you know, previously we used to say A and here electrons. Now instead of electrons, what we are using? Orbitals. That is only the difference. Clear? So these are about the salient features of hybridization. Now next we will discuss. We have to discuss here conditions for hybridization. Clear? So now these are important conditions for hybridization. After this, so we will discuss the types of hybridization. Then we will get the clarity what is exactly hybridization, what are hybrid orbitals, and how they will have equal energy. That all we will discuss. Clear? So what are important conditions for hybridization? Okay. So these are
orbitals present in the valence shell of the atom are hybridized. Always which orbitals will be hybridized? Valence shell orbitals. Clear? Valence electrons we use it to. This is simple. Previous we used it to say electrons. Now we will say orbitals. That is only the difference here. Clear, my got my point? So in this one, orbitals present in the valence shell are hybridized. Clear? Valence electrons are valence orbitals are present, and those are involved in the hybridization. Clear? Orbital undergo hybridization should have almost equal energy. Previously we have discussed this point. To involve in the hybridization, the atomic orbitals which are involving in the hybridization should have almost equal energies. Then only those type of orbitals only involved in the hybridization. Clear? That is the second point. And the promotion of electron is not essential conditions prior to hybridization. Promotion of electron means I said ground state, excited state. This is not necessary for all time. Sometimes it is necessary. That is only the extension. Not essential condition. Clear? So that is. And it is not necessary that, very important this point, it is not necessary that only off-filled orbitals participated in the hybridization. Clear? So we will previously use it to say only off-filled atomic, what it is, overlapping means orbital overlap concept we have discussed. There what we mentioned, only off-filled atomic orbital overlap to form a covalent bond. But here, what it is here? Not only off-filled orbitals. Clear? Means it is not necessary, and here only off-filled orbital to participate in the hybridization. Clear? In some cases, even filled orbitals of valence shell take part in the hybridization. One example is there, ammonia example it is there, water molecule example there, and there we will use this point. So these are what is important conditions for hybridization. Clear? Next we will go for what it is, put the heading types of hybridization. Clear? So next one is types of hybridization. Clear? So what are those types, and we will discuss one by one. Clear? Put the heading types of hybridization. Types of hybridization. Then, so the first one is sp hybridization, or we can say diagonal or linear hybridization. Put the first one, diagonal or linear or sp hybridization. sp hybridization. Clear? What is this sp hybridization? Clear? When one s orbital and one p orbital of the same atom are mixed together and form two new hybrid orbitals. Clear? And this type of hybridization we will call as a sp hybridization, and the two newly formed orbitals we will call as a sp hybrid orbitals. Clear what it is? Right. What it is here? Right here. When one s and one p, when one s and one p atomic orbital, or simply write p orbitals belonging to the same shell of atom, same shell of what it is here, same shell, main shell of an atom are mixed together, an atom, or simply you can say when one s and one p orbital belonging to the same atom, and already same shell means valence shell only. Clear? Same shell of an atom are mixed together mixed together, clear ma? Mixed together and to form two new equivalent orbitals, to form two new equivalent orbitals, clear ma? And this type of hybridization is called hybridization is called, what it is here, is called sp hybridization. The two new orbitals we will call, what it is here, sp hybridized orbitals, clear ma? You can simply say, and the sp hybridization and the new orbital formed are called, the new orbital formed are called sp hybrid orbitals, clear ma? So this is about what it is here, and what it is sp hybridization. How it is sp hybridization, clear ma? You see now. So you already know that we have and one s orbital, clear ma? S orbital I will write, and there is a p orbital, and another one is another p orbital, and next one is pz orbital. Just assume like this. This is what which orbital? S orbital. This is px orbital, and this is py orbital, and this is just assume pz orbital. Clear ma? In this one, so which orbitals are mixing here? Clear ma? So px, py, and pz. Clear? One s and one p. It can be px or sometimes pz also py. Whatever it be. Clear ma? So one s and one px, and they are mixed together and form. How many orbitals are in one atomic orbital? 2. So how many hybrid orbitals you should form? 2. So what that 2? How they will form is, they are means in the linear shape. Why? Because if they are in the linear shape and representations will be less, like you say previously we have mentioned, 2 bond pairs are there and they occupy the position in the space in order to minimize their energy. Same orbitals also in the same way. So how this sp2 hybridized orbital? This is one I already mentioned how to represent the hybridized orbital, and another one is there, and this is clear ma? So this will be called as a sp hybridized orbitals. Clear ma? So this is what is called sp, and here also what is called sp. Clear ma? So how many sp hybridized orbitals we have? And 2 sp2. This is one and this is one. 2 sp2 hybridized. Clear? Now, by using this, when these 2 sp2 hybrid, previous what it is? Previous only directly these atomic orbitals are involved in the bond formation. But here what it is? First of all, these atomic orbitals are mixed up, and then we are getting hybrid orbital, and this hybridized orbital involved in the what is here? Bond formation. I will take one simple example, then we can clearly understand what is this sp hybridization. Clear? Previous directly atomic orbital should be involved in the bond formation. Now hybrid orbital will involved in the bond formation. Why? Because you see, the previous and one px orbital, one s orbital if you take, and bond formation you see, and if you bond formation takes place, I mentioned here previous px and px is there, one s orbital, one px orbital, and overlap. Clear? But there which bond you will get here? One bond you will get, but angle of what's 90 degree there, because s orbital is different, p orbital are different, p orbital is different. So but in this case s orbital different and p orbital different, but after mixing both are same only now. Got my point now? That is like that. Now I will take here one example, formation of BeF2. How this will be formed? Clear? Beryllium. Beryllium means you already know what is the beryllium. Beryllium ground state. GS means ground state. 1s2 2s2, isn't it, man? So this is 2 electrons are present, and here another 2 electrons are present. Clear? So here this is 2s. But what is the excited state? Es means what is my excited state? And you know this is 1s orbital. These are which orbital? 2s orbital. I will write this side. Clear? So it is 1s orbital and 2s orbital. Suppose if I write beryllium here. Beryllium means what is my GS. GS means what is my? And we have to take which orbital involved in the hybridization? Only valency. Valence means if I write 1s2 2s2, which one is the valence? This is, so I will not write this. So here there are 2 s electrons in excited state. So next one 2p will come, isn't it, man? This is 1, and the next p orbital will be there. 1 electron will come here. Then what happens? You see these two, 1 s orbital and 1 p orbital, they mix up. Clear, man? They mix up and gives what it is here? 2 sp hybridized orbitals. This is 1. This is 1. Clear? So this is s orbital, this is p orbital. You are getting what it is, man? This is sp, and this is also which one? sp. It is having one unpaired electron. One is having one unpaired electron, and another one is also having one unpaired electron. Clear, mates? Now this sp hybrid orbital will combine with the f orbital. F orbital means what it is, man? Fluorine. Fluorine means what you will get. So this is hybridized orbital. Clear? So what is this hybridized orbital? Like this. This is hybridized orbital. sp hybridized. Clear? So this is 2 orbital. One is sp and sp. Here 1 electron and here 1 electron will be there. Now I will write this side. Then what you will get to see, one? p orbital. Clear? See now p orbital. What is the p orbital here? f electrons, if you take 2s2, 2p, 5 means what it is there, and here 2 electrons, and here 5 electrons, 1, 2, 3, 4, and what is 5? Clear here? 5 electrons are there, and this is 1 unpaired electron is there. This unpaired electron orbital and combined with the 2 sp hybridized orbitals. Clear? So it is which one? P orbital. P orbital means, and how they will form. Clear? So very clearly I will write. So this is. So this is 2 sp2 hybridized orbital. Clear? sp hybridized orbital. Now this is p orbital. This is p orbital of fluorine, and another one is what is one? P orbital of fluorine. Clear? This is what it is. Beryllium. Beryllium 2 hybrid orbital. Here 1 electron is there, here 1 electron, and here 1 electron. So that's why here 2 electrons will be there. We will not represent here electrons. So that's why I am not representing. 2 electrons means what one? Be 1 bond and Be 1 bond. That is hybridization. Clear? And remaining this orbitals. See what this is? P orbital is there. Now what happened here? You are getting beryllium and F and beryllium and F, because both are same. So that's why how much bond length is here, how much, and here also bond length will be same. Clear? So that is the, so if you take here the bond angle is 180 and bond length also same. Why? Because here Be is having what is here. It is a, what it is, linear shape. So both are having same hybridized orbital. So the formed bond also formed is here equal bonds. Clear? So in this one, the bond angle is what is here 180, because here you see this is 180. Hybridized orbital is there, expected. So what is the shape here? Shape is a linear. What is the shape of hybrid orbital? That is the shape of that molecule. You remember that. Clear? So what is the shape of hybrid orbital here? Previous this is hybrid orbital. What is the shape? Linear. So that's why after overlapping of the empty orbital, means off-field orbital of the off-field orbital of p orbital, and you will get what it is here. Clear? So this is 180. Now in this one, each hybrid orbital has a, what it is here, 50% S character and 50% P character. Why it is 50% S character and 50% P character? This is hybrid orbital. This is what it is, sp hybrid orbital. How much angle here? 180. So this is sp, and s character how much, 1s is there, 1 by 2 into 100. There, how much here? 50% of s character. This is which character? S character. P character means how much, Here also 1. Total how many orbitals? 2 into 100. How much it is, 50%. So P character also 50%. Each hybrid orbital having the 50% of s character and 50% of P character. So this is about the what it is, here diagonal or linear or sp hybridization. Simple. Once again. So what is the here condition first of all? So here you may get slight confused. I will again once again I will just clarify that. Clear one? See now. So in this one, what is the sp hybridization? One s orbital and one p orbital. They mix up and give one means two sp hybridized orbital. This is two sp hybridized. One sp hybridized orbital, another one sp hybridized orbital. I mentioned how to represent this. So this is how much angle here? 180. Clear? This is sp hybridized orbital. Clear? In this case, I have taken here one simple example, beryllium F2. Clear? So first of all, the central atom valency shell orbitals are mix up and form a hybrid orbital. What is the central atom here? Beryllium. Beryllium, and excited state electronic configuration is 2s, and what it is here? 2p. 1s. Suppose just assume 2px. Clear? So these are empty orbitals. These two orbitals, first central atom valency shell unoccupied means orbitals. First of all, what is undergoing hybridization. When they hybridize, and how many orbitals you will get? 2 sp hybrid orbital. 2 sp hybrid orbitals you will get. That is here. 2 sp hybrid orbital. Because 2 atomic orbital, 2 sp hybrid. What is 2 sp hybrid orbital here? That is one I mentioned. This is clear. So how to write this is first of all, this is 1 and this is 1. Clear? This is what it is, beryllium that I have taken. Now beryllium has to make bond. I have taken example which one? BeF2. It has to make a one bond with the fluorine and one bond with the one fluorine and a bond with the another fluorine. Fluorine I have already written here. Fluorine what it is, 2s2, 2p5. 1, 2, 3, 4 and 5. So you know that after forming the hybrid orbital, this hybrid orbital involved in the overlap. In the overlap, which orbitals will involve? Orbital having the off-field electron. That is this orbital involved in the, because this orbital already filled. This is which orbital? P orbital. Suppose px. This is py, 2py orbital, and this is which orbital? Pz orbital. That is only. This is pz orbital overlap, and this is another pz orbital of another fluorine, and this you will get what it is here. This is one bond. Overlap means what is here? 2 electrons will be there, because here 2 electrons. One s in 2 sp orbital. 1 electron in 1 sp orbital. 1 electron in 1 sp orbital. Because we will not talk about the electrons, so that's why we are talking about orbitals. So, and overlapping means one bond you will get, that is BEF. And what is BEF? This is 180 degree. So, what is the S character? Percentage of S character here 50%. Percentage of P character here how much? 50%. This is about what is sp hybrid.